problems that you just worked on. So what I want to introduce to you now is the third and final method that we're going to use for solving linear systems, and this is called elimination. There we go, elimination. Because what we're going to do is we're going to find ways to eliminate one variable or the other from our equations. Now, in some ways, you could think of this as a very advanced form of substitution, and I don't know that that's going to be very helpful to you. But there are some links that, if you dig deep, you'll find. But let me explain to you exactly what we mean by elimination and how it's different than substitution. Take a look at the two equations I've put up here. I have 2x plus y equals 4, and x minus y equals -1. Now, if I were to jump straight into doing this through substitution, I would solve one of these equations for x or y, probably the second one, because that would be one step. I could add y to both sides and boom, I've got x isolated, and then I could substitute it into the other equation and be on my merry way. But there is a clever idea that we're going to take advantage of that we could use to save a step or two. And with more complicated systems, maybe a step or 4 or 5. And it's called elimination. And here's the idea behind it. You know that in algebra, whenever I need to solve an equation for whatever reason, for whatever variable, I am allowed to perform operations on both sides of the equal sign as long as I do the same thing. So, for example, very simple idea here. If I take 2x equals 4, I am allowed to divide both sides of these both sides of the equal side by 2 in order to simplify the equation and get x equals 2. Or one that's a little bit closer to what we're actually going to do today, if I were to say take x plus 6 equals 9, I can subtract 6 from both sides. This is nothing new. I'm just reminding you that the idea here is I'm allowed to perform operations on algebraic equations as long as the operations are the same on both sides of the equal sign. So let's go back to this system. And let me show you how I'm going to use a very clever interpretation of the same when I subtract or add something to these equations. So I am going to add the same thing to both sides of this equation. And the thing that I am going to add is this whole equation. Let me explain. What I'm saying I can do here is I can take this whole equation and I can add it to the equation above it. And why am I allowed to do that? Well, because on both sides of the equal sign, I'm adding, and I'm adding the same thing. But Mr. Leash, on one side you're adding x minus y, and on the other side you're adding -1. But as some of you are probably already screaming at the screen, but they're equal. So that means they're the same. So I'm adding the same thing to both sides. And watch how this gets clever. So if I added 2x plus y and x minus y, now remember I'm adding everything here, so I'm going to add the x, and 2x plus x is 3x. And I'm going to add the minus y, so plus y plus -y is 0. 0? Look, I have eliminated the y variable. Over on the right hand side, it's a little bit simpler. 4 plus -1 is 3. So I've taken these two equations, and through adding them together, I've eliminated one of the two variables, and now I have a ridiculously easy equation to solve, which looks like this. And I get x equals 1. And just as before, now that I know what one of my variables is, I can now substitute it into one of the equations to find the other variable. So I'm going to substitute it into the bottom equation, x minus y equals negative 1, because that looks easier to me. So I'm going to make this 1 minus y equals negative 1. And then I'm going to subtract 1 from both sides, and I'm going to get negative y equals negative 2. And that means that y equals 2, so that I get the coordinate 1, 2 as my solution. Let's just verify that this worked. Okay, so I'm going to check this. And when I check this, I'm going to try 1 comma 2 into 2x plus y equals 4. So I'm going to do 2 times 1 plus 2 equals 4, and I get 2 plus 2 equals 4. Oops. I started to put a check mark there before I finished. Let me try that again. Equals 4. Hey, that worked. Let's check it with the other one. So x minus y equals negative 1. So 1 minus 2 equals negative 1. Yep, that worked. So hey, my system is solved, and I found the point. So, one more time. The key to elimination is I'm allowed to add or subtract the same thing from both sides of an equation, as long as they are the same on both sides, as whatever I'm adding or subtracting. And because this whole equation has an equal sign in it, right? So what's on the left is the same as what's on the right. I'm allowed to add one of those things on the left-hand side of the equation and the other thing on the right side of the equation, because they're the same. Let's take a look at one more example. So you've seen addition in action. Let's see if we can do one that is subtraction. Let me see if I can find an example here on my cheat sheet over here on the left. I'm not finding anything useful, so I'm going to make one up on the fly. You know what? I think I might pause and make it up. Hold, please. Hey guys, thanks for waiting. I know for you that wasn't a wait, but for me, it took me a whole 2 minutes to come up with this new system of equations. I wanted to check and make sure that the math is a little bit easy here, because even though elimination works quite well when our points are not lattice points, I want to make sure that we're focusing on the technique rather than any complexity with fractions and things like that. Trust me, when you get to the work on your own, there'll be plenty of complexity for you to play with. I'm a giver. I give. Okay, so here we go. I have two systems, a system here of two equations. Again, notice that a lot of these for elimination are already set up in standard form. That's because standard form is by far the easiest way to utilize this particular skill. If they're not in standard form, then you're either better off using substitution, or one of the first things you're likely to do is to put it in standard form, or to get it close to standard form, because you want it to be easy to see what it is you need to do in order to do the elimination. So if I look at these two equations, I'm going to be taking one of these equations and I'm going to subtract it from the other one. And the reason I'm going to subtract it is because if I notice here, I have two variables that are exactly the same. They have the same coefficient, 1, and they're both x. So if I want to eliminate that particular variable, subtraction is the way to go. So here I go. I'm going to subtract x minus y from x plus 4y. So x minus x, that's my 0. So this part here becomes 0, which I don't need to write. And then 4y minus a negative y gives me a difference of 5y. So the x's went away. I have successfully eliminated them. And now I'm down to just y's. And then over on the other side, I'm going to subtract positive 2. So 17 minus 2 is 15. This becomes a trivial example of solving. I get y equals 3. And then I can take this and plug it back into one of my other equations to find the x. I'm going to choose the one that has, excuse me, that has the simplest expressions. So I'm going to choose x minus y equals 2. And I'm going to substitute in the 3. And I'm going to get that x equals 5. So my solution is 5, 3. I'll leave you to check that for yourself to make sure that Mr. Leash hasn't done anything silly. I would check it because Mr. Leash is known to do silly things from time to time. And, you know, I'm a little bit wonky. It's late at night. So this is the basic idea behind elimination. In general, I'm going to have something with y's and x's here and something else with y's and x's here. And I'm looking for either opposite variable expressions in one variable or the other, or I'm not going to bother to solve this so I can make the numbers crazy if I want. Or I'm going to look for something where I have the same variable expression in each equation. So here, this is going to be solved by adding one equation to the other. And this one is going to be subtracting one equation from the other. And it really doesn't matter which equation you do the addition or subtraction with. I tend to go top to bottom usually, but you can rearrange them. You can put one on top of the other. It doesn't make any difference because the whole goal is you're going to make one of these variables go to 0. And it doesn't matter what order you do it in if your target is 0. Right? Okay. So before I leave you to practice some of this, I want to point out that this works even if you don't see variables that are either the same expression with the same coefficients or variables with opposite coefficients. I drew those arrows in the wrong order. This is the side that has the same coefficient. This is the side where I have opposite coefficients. What happens if I have something where neither of those things is going on? What if I don't have any common coefficient terms? So what if I have something like this? 4x plus 5y equals 12. Yes, I'm looking up at my cheat sheet now because this one I don't have to think about. And 2x plus y equals 8. Now, I could fall back on substitution. Substitution is always an option. But elimination is pretty fast as long as I can make something true. And what I'm trying to make true is I'm trying to make one of these variable coefficients the same or opposites. So either I want my x's to have the same variables or the same coefficients or opposite coefficients, or I want y to have the same coefficients or opposite coefficients. So if I inspect these two, that doesn't happen. I don't have either of those things. But I can force it to happen. Because just like I can add and subtract to both sides of an equation, I can also multiply or divide both sides of an equation. So here, for example, I could take this equation. Whoa, stop right there. So, students, you may have noticed that I've disappeared from the corner of the screen. That's because as I was preparing to get these plans together for your substitute, I was watching my video to make sure that everything worked, and I realized that I had missed something fairly important in my edit. I did the math wrong. Hey, it happens. And I considered for a minute asking you to see if you could figure out what I had done wrong. But then I thought, this is the first time you're seeing this skill. I probably want to make sure that you see it done correctly. So here's what I'm in the process of doing. I mentioned that I can force one of these equations to have the same or an opposite coefficient in a variable term that works with the other equation. And I'm going to multiply this bottom equation by 2 to achieve that effect. Here's where I made a mistake. So When I multiply this by 2, on the left-hand side, I'm going to get negative 4x plus 2y. And on the right side, I'm going to get 16. Now, in the bad version of this edit, I forgot to multiply the right-hand side by 2, and I did the whole problem and obviously got the wrong answer. So, lesson to you is a common mistake is to forget to multiply both sides of the equation when you are trying to do this technique. Don't check yourself and make sure that you haven't done that. So, when I've multiplied the bottom equation by 2, now, if I line it up with the top equation again, you can see that I suddenly have a variable expression where the coefficients are opposite, which means I am set up now to do my elimination. So I'm going to add everything on this side. I'm going to add everything on this side. And I'm going to get 4x plus negative 4x. Well, that's 0. That was the goal. I got rid of one of my variables, and I've got 5y plus 2y, which is 7y. And over on the right-hand side, I have 12 plus 16, which is 28. Again, I now have a very simple process for solving, and I get y equals 4. I was kind of hoping this would come out to be something that was a little bit funky, maybe a fraction, so you could see that fractions aren't to be frightened of, but, it is what it is. So I can now take this and I can shove it back into one of these equations. In fact, I have sort of a plethora of choices here. I could put it back into this equation, or this equation, or if I thought it would be useful, I could even put it into the one that I manipulated to make this whole process work in the first place. Any of them will do. I just need to replace something with y, replace y with something in order to find the x. And I have all those different choices. So I'll do the bottom one here because, again, that looks like it's going to be the easiest since y doesn't have any coefficient. And I will get negative 2x plus, and I'm going to make that a 4. So I'm going down here, equals 8. So I get negative 2x plus 4 equals 8. Subtract 4 from both sides. Subtract 4, subtract 4. Negative 2x equals 4. Divide by negative 2. And I get x equals negative 2. So my solution is negative 2, 4. All right, so now you've seen everything there is to see when it comes to understanding elimination. Don't be afraid to go back and watch parts of this video again if you aren't sure of what you're doing or if you're trying it for yourself and you're like, wait, I'm confused. But just in general, the goal here is to find a y or an x term in both equations that will allow us to either add or subtract the two equations to one another in order to eliminate one of my variables. So here, make 0. You're now ready to go on to the next bit of work that I have for you, and you should finish that up for coursework. And then tomorrow, during class, I will clear up any confusion. We can ask questions. And then with whatever time we have left, which will probably be prodigious, we'll work on some problem-solving techniques and see some of these different techniques in action with more interesting sort of problems, I hope. All right. Talk to you guys later. Don't be afraid to come by and see me if any of this really blew you away. I'm on campus.